All right, so now we're going to move on to section 8.2. And in this one, it is special right triangles. All right, if I gave you a problem like this before, and say this was 30 and this was 60, and I just said that this is equal to 2. Before today's lesson, we wouldn't be able to solve for this because the only way that we know how to solve for right triangles is by using Pythagorean theorem, a squared plus b squared is equal to c squared. And right now, all we have is one side length. We don't know our b and a hypotenuse. So we can't solve this problem as is before learning today's lesson. But now today's lesson, we're going to learn in two different videos. The first video, we're going to learn about the 45, 45, 90 triangle. And then in our second video, we're going to learn about the 30, 60, 90 triangle. So these are two special right triangles in which they have properties that allow for you to use shortcuts to determine the side lengths without Pythagorean theorem. All right, so it allows for us to use shortcuts so that we could actually solve for this triangle here, even though we only have one side given. But it only works for these two, the 45, 45, 90 triangle and the 30, 60, 90 triangle. Right? The one in this video that we're going to discuss is a 45, 45, 90. All right, so now let's talk about this one. So first off, a 45, 45, 90 triangle, we know we have two congruent angles, so that means that the sides opposite of them will be congruent. And this means it is an isosceles triangle. So our two sides of the triangles, or the two legs, are going to be the same. So these two legs will have the same distance. And then our hypotenuse is equal to the leg times the square root of 2. All right, so this is just a formula that you're going to have to remember for 45, 45, 90 triangles. And I'm going to have you write it out whenever we're solving this, as you will write out hypotenuse is equal to the square root of 2 times your leg. And then whatever you're given, you can solve for the other one. All right, so let's go ahead and do a problem for this. So we're asked to solve for h, our hypotenuse. So we know that it is a 45, 45, 90 triangle because they give us that the two angles are 45. So we can then write that our hypotenuse is equal to our leg times the square root of 2. And now we look and say, all right, well, we're given that this leg is equal to 9, so I can substitute 9 in for leg, and I can substitute h in for hypotenuse. So h is equal to 9 times the square root of 2. And there's nothing else I can do for this, so that is simply what h is equal to. So we can simply quickly and easily to say that this is equal to 9 root 2. All right, so it allows for us to solve for these questions a lot quicker than if we had to use Pythagorean theorem. If we had to use Pythagorean theorem for this, well, we could identify that since these are the same, that the opposite sides have to be the same, so we could say this is 9. Then we would have had to say, well, 9 squared plus 9 squared is equal to 8 squared. So then 81 plus 81 is equal to 8 squared. 8 squared is equal to 162. Square root from each side. H is equal to plus or minus square root 162. We know we would cancel out that negative, and then we would simplify square root of 162 as 81 times 2, and then the square root of 81 is equal to 9. So we would still get the same answer, but this one was a lot faster and a lot easier, I think. It's just you need to be able to remember this formula that we'll call it, that we will use to solve for this. All right, so there's one more example that we're going to do in this video, and then that's it. So then the last example is, what is the value of x? All right, so we just want to know what the value of x is. So once again, we know that it's a 45, 45, 90 triangle because they give us the degrees. They could also say here that the angles are congruent. But now we know our hypotenuse, since it's 45, 45, 90, is equal to our leg times the square root of 2. That's the formula that we will use. Well, our leg is equal to x, and our hypotenuse is equal to 6. So we'll substitute that in. 6 is equal to x times the square root of 2. So if we want to solve for the square root of 2, if we want to solve for x now, we have to divide by the square root of 2. So x is then equal to 6 over the square root of 2. So we can't leave a radical in our denominator, so we have to do what's called rationalize. So we will rationalize the denominator. and then we will multiply the square root of 2 over the square root of 2. Now the reason why we're doing this is equal to 1, so it's not changing the value of this fraction at all. And if we do the square root of 2 times the square root of 2, this is equal to the square root of 4, because we can multiply what's on the inside since our indexes are the same, and the square root of 4 is equal to 2. So by doing that, it eliminates the radical in our denominator. So after we multiply, x would then be equal to 6 times the square root of 2 over the square root of 4, which we know is going to be 2. So x is equal to 6 square root of 2 over 2. And then we will simplify one more time because 6 and 2 can reduce. So 3 square root of 2. So that means each of these sides is equal to 3 times the square root of 2. All right, and that is it for this video. There's no more examples that we're going to do. And this just makes it a little bit easier and quicker to solve for this than what we would have had to have done before. So this video was all about the 45, 45, 90 triangle, and then the next one's going to be about the 30, 60, 90 triangle.